given the following information about them. In Cafe A, you're provided the calorie information for each dish in its menu. In Cafe B, you're not provided such information. Everything else about these two cafes remains the same. Now, I'm going to ask you a question. Unfortunately, you can't respond, but how many of you would choose to go to Cafe B, where you wouldn't have to receive calorie information? Yeah, you could raise your hand, put it in the chat. Yeah, and you wouldn't receive information about the calories that are in the food that you choose to eat. It's interesting to think about the reasons why we choose to avoid information. For example, in this cafe, if you receive calorie information about how many calories are in the pasta dish you order, does it make you feel bad? How does it make you feel? Does receiving calorie information change any preferences that you may have about making decisions on going out to eat, where you go to eat? For our study, we're looking for these underlying reasons for information avoidance and seeing if they can explain age differences in information avoidance. So you may be wondering, why look specifically for age differences in information avoidance? Our project is looking at how older adults may avoid information differently from younger adults, because research has shown that older adults tend to seek less information than younger adults do. This age difference in information seeking and potentially in information avoidance has important implications for how older adults may make decisions in various contexts, including making informed decisions about their own healthcare. Because we know from the literature that there is decreased information seeking among older adults, we hypothesize that information avoidance is increased among older adults. Despite there being a lack of research focus on age differences in information avoidance, there has been research conducted on information avoidance in general, which has supported reasons for information avoidance that are similar to reasons for why older adults tend to seek less information. Decision makers who choose to avoid information and older adults want to protect against negative feelings. They also tend to avoid future decisions that they don't want to make. So in other words, decision makers who avoid information and older adults also have decision-making preferences that they want to preserve. This leads us to two research questions that are related to our hypothesis. The first question looks at the role of concerns for protecting feelings and concerns for preserving decision-making preferences and how they may explain age differences in information avoidance. Our second research question looks at the role of variables that change with age and seeing how they may explain age differences in information avoidance. For our study, we conducted an online survey and recruited 195 participants. And we provided these participants with 3 information avoidance tasks, and each task contained a health-related scenario. Within each scenario, we also provided a choice between 2 options for participants. One option provided information that people may want to avoid, and the other option didn't provide such information. We then asked participants to indicate their preference between these 2 options along a slider. So for example, in that cafe scenario that I brought up earlier in this presentation, we asked participants to indicate along a slider if they preferred to go to a cafe that provided calorie information or the cafe that didn't provide the calorie information. We also looked for the motives and the reasons for why people chose to avoid information or not. So again, for that cafe scenario, we asked participants how concerned they were that the calorie information would make them feel bad or would limit their enjoyment of eating out. This helped us to assess how concern for protecting feelings may have been a motive or reason for information avoidance for people. We also asked participants about how the information, for example, the calorie information, would impact their preferences in making decisions. So from participants' responses for information avoidance across these 3 scenarios, we found that information avoidance was not increased among older adults. So this finding was counter to our original hypothesis. We then looked at our first research question, again, looking at that role of protecting feelings and the role of preserving decision-making preferences, and how they may explain age differences in information avoidance. And we found that among older adults, there was overall less concern for these information avoidance motives. Among older adults, they were less concerned about information impacting their feelings, and they were less concerned about preserving their decision-making preferences in choosing to avoid information or not. And this finding was surprising to us, given that the literature suggests that how aging may influence decision-making would point that older adults would be more protective of their feelings or more protective of their decision-making preferences. We also looked at how these two types of motives for information avoidance were associated with information avoidance. And we found that concern for protecting feelings as a motive for information was positively associated with information avoidance, although not significantly. And we also found that less concern for preserving decision-making preferences was associated with information avoidance. So considering that, we found that both of these two types of motives could potentially play a role in influencing information avoidance, we controlled for these two types of motives and looked at the association between information avoidance and age, and we still found that age was not a significant predictor of information avoidance. So we also looked at our next research question, looking at how variables that change with age may explain age differences in information avoidance. And we were looking at variables that measure demographic, cognition, and socio-emotional health. And we found that 7 variables, which measured time horizons, emotional health, cognition, and personality, these 7 variables were highly varied with age. So we controlled for these 7 variables and looked at the association between information avoidance and age. And even after controlling for these variables, we still found that age was not a significant predictor for information avoidance. So to summarize our findings, overall, we found that information avoidance was not increased among older adults, even when we controlled for a variety of motives for information avoidance, and even when we controlled for variables that change with age. So this leads us to the big question of why. Why is it that the case that our findings countered our hypothesis? And we think there may be 2 factors to this. The first is that we used a slider-based response format in assessing information avoidance. This means that participants could choose a neutral position when we prompted them to choose between the 2 options. When we prompted them to choose either to receive information or to avoid information, they could choose the middle of the slider and indicate a neutral position. The second reason may be that all the scenarios that we chose for our information avoidance tasks were health-focused. This may have discouraged information avoidance, especially among older adults, because older adults particularly value health-related information since physiological health declines with age. So overall, we found that common reasons for information avoidance, which were protecting feelings and preserving decision-making preferences, these reasons influenced information avoidance and were associated with age unexpectedly and sometimes inconsistently with the literature. However, our results suggest that interventions to limit avoidance of information in decision-making should be tailored to target age groups, considering the associations between age and common reasons for information avoidance, and despite our finding that age was not a predictor of information avoidance. Now, to address the limitations of our study that I've highlighted, we are conducting a follow-up study with a forced choice paradigm for participants to choose one of 2 options, whether it's choosing to avoid information or not, without being neutral. And we'll also be including scenarios that are not limited to a health focus in the scenarios that we have for our information avoidance tasks. Thank you.
Okay, thank you so much, Stephanie. That was really amazing and a really great start to our conference. We'd now like to open the Q&A round for Stephanie, and the audience can type their questions in the chat or privately message me, Neha, or Daniel. So we'll give a little bit for some questions to start rolling in. But I guess that I have one that we can start with.
There's
So-
two
oh.
questions in the Q&A box if you want to
Okay,
check them out.
let me take a look at those.
Yeah.
All right, so our first question is whether you take into account the socioeconomic status of the participants, because wealthier, more educated individuals may want to be provided with and value information regarding their calorie intake compared to those in lower socioeconomic groups. Sorry, go ahead.
No worries. Yeah, in our study, like I mentioned earlier, we looked at variables that measure demographic, socio-emotional health, cognition, and within demographic, we also looked at income level and education level. And so we looked at how any of those covariates may have been associated with age. And if they did, we would control for that and looking at the relationship between age and information avoidance. But in our results for our study and looking at these covariates within demographic, we didn't find that those variables significantly varied with age. But that is something that we did measure in gathering results in our study.
Okay, cool. And our next question is whether or not gender differences were taken into account.
So that was also included in our measuring for covariates under demographic. We had, we collected data on whether participants between males and females, although we didn't separate based on gender in looking at these regressions or analyses. Although that's something that's an interesting thought to consider.
Cool. So we have another question. If you could run a set of new scenarios not focused on health for evaluating information avoidance, what would they look like?
Yeah, so that's exactly what we're trying to do with this follow-up study. And we wanted to eliminate any age bias that might be inherent to health-related scenarios. So for one example, we have a scenario that is centered on like the purchase of wood furniture. So it's prompting or presenting this information of the scenario of buying wood furniture, and it's prompting participants to indicate whether or not they would want to receive information about deforestation along with their purchase of furniture. So that's just one example.
Cool. So we have another one. Given the literature focusing on age differences in information seeking more often than age differences in information avoidance, how does information avoidance differ from information seeking? And don't you not receive the information either way?
Yeah. So for the focus on research in information avoidance, that really helps to identify any barriers there would be for people using information that is presented to them, whether or not they're actively seeking it on their own. So especially in a medical and healthcare context, identifying these barriers can be very helpful and relevant in encouraging people, especially older adults, to make more informed decisions.
Great, and we've just got a couple more here. So were there any confounding factors that were addressed in the design of the experiment?
So with our collection for covariates and the variables for demographic, socio-emotional health, and cognition, we tried to look for any relationships there with age and account for that in looking at associations with information avoidance and age.
Okay, and we have another. So what was the most fascinating thing you learned while conducting this research? An unexpected discovery or something like that?
So I'd mentioned this earlier. I was pretty surprised by our finding when we were looking at the motives for information avoidance and their relationship, their association with age, because given the literature on age effect on information seeking, given the literature on information avoidance, there seems to be a lot of similarity between the motives for avoiding information, a lot of similarity with the motives for older adults tending to seek information less. So I was surprised that our finding wasn't super consistent with that. That keeps it more interesting and exciting because that's something that we can dig into a little more.
Okay, and I think we'll end with this one just for time's sake. So, what is most important in your life, education or compassion?
If education or compassion is more important?
Yeah, that's what the question's asking.
For my own life? Sorry, I'm trying to wrap my head around this question. That's an
Take your
interesting question. I mean, I think I value both, but I think overall, without compassion, I think it's hard to make the most out of any education, any learning experience, any growth. Without compassion, it's really hard to, you can learn a lot of things, but if you're not compassionate, it's going to be really hard to be able to spread that and like do good with that. So
great.
Yeah.
So that was our last question for the Q&A round for Stephanie. Thank you for the wonderful questions from the audience, and thank you for the great responses to the questions and an overall great presentation, Stephanie.
Thank you.
Great. Hi, everyone. My name is Neha. I'm a member of the CURBx committee, and I'm excited to introduce our second speaker, Xuan Ciel. She is a senior studying political science with a regional focus on China. Her main research interests include information politics, cyber activism, and social media. So without further ado, take it away, Xuan.
All right, thank you. And huge shout out to Stephanie for a great story about people avoiding information. So my research is also related to information, but more specifically, how information avoids people. And the title of it is Data Fraud on China's Social Media During COVID-19 Outbreak. So if you have heard one thing or two about China's social media, you have heard about censorship. And the popular imagination of censorship goes something like this. You're sitting at home and you're playing on your phone, and you're tweeting something that's negative about the government. And within seconds, you realize the tweet you just posted is gone, and then your account is probably blocked for days for violating, relevant regulations. And my job with this research is really to put that conventional wisdom to test in light of the coming pandemic. Here are some of the interesting stories that unfolded during China's COVID outbreak. The first picture is a picture of Dr. Li Wenliang, who was the whistleblower, one of the first people that went public with the story of COVID and was subsequently punished for spreading misinformation online. And the second picture is of Wuhan Red Cross, which was charged with the duty of distributing medical supplies. And that ended up with a huge corruption scandal. And finally, this is the diary of Fang Fang, who is a Wuhan-based writer. And let's just say she painted a very different picture about Wuhan than the official media. What is common with all these stories is that, one, they're all very influential domestically and internationally. But second, they really embarrass the Chinese government. So conventional wisdom would say, well, these stories have zero chance of survival on China's social media. They must be gone. But is that the case? So I did a quick reality check on China's largest social media platform, Sina Weibo, which is basically Twitter for China. And as you can see, not only did all three stories survive, they're really thriving. If you zoom in and look at the numbers here, there are millions of posts being generated about these topics, even until this day. So this poses a great paradox. Why are these topics still present on China's social media? Does it mean that the whole censorship thing is just a myth? So my answer to this, just to spill the tea, is that no, censorship isn't a myth, but we just have better ways to do it than deleting posts and blocking accounts. But let's just take a step back and see how the whole thing works. So here's a snapshot of Weibo's trending list. And let's zoom in a little bit and put it next to a snapshot of Twitter for those of you who are not familiar with China's social media. Essentially, the trending list is a list of topics that are supposedly most popular or hotly discussed at the moment. And as you can see, the topics are listed in blue, ranked from the most popular to least popular, based on this gray number next to it. So one thing that we should know about trending lists is that they're literally everywhere on Weibo. So you open your homepage, you open your timeline, it's there. You try to search anything using the search bar, it pops out. So it has a great agenda setting effect on the public discourse. Everyone sees them and everyone sort of takes it as given that these topics are genuinely popular. But here's the question, what is this mysterious gray number next to the topic? Unfortunately, Weibo never really goes public with their algorithm for calculating this number. So we can't really say if this is a function of likes, posts, retweets, searches. We're not sure about that. But for the purpose of my study, all that we need to know is that this number is officially designated as the popularity index, which is essentially, how popular this topic is as recognized by Weibo. So this provides us with two different places to test information manipulation. The first is obviously with the number itself. Is the popularity index manipulated? And the second, but relatedly, is if, let's say, the popularity index is good, is there some kind of manipulation with the ranking of these topics? So is Weibo actually ranking topics and giving each topic the proportionate amount of trending time based on the popularity index, which they generated themselves? With these two questions in mind, let me proceed to the first investigation of popularity index. So for this, I apply the Binford's law. So this is the law of first digit, which basically says for any large data set that is free from human manipulation, the relative distribution of the first digit of each number follows this pattern. So for example, numbers that start with 1 appear most frequently with a frequency of 30% and followed by numbers that begin with 2, that's around 18%, so on and so forth. So this is what the distribution should look like if the data set is free from manipulation. Now let's put that against the topics that are related to government scandals in China during COVID. As we can see, the dashed line represents the natural distribution under Binford's law, and the blue line represents the distribution of COVID government scandal. Unsurprisingly, somewhat, you can see these two lines do not really map onto each other, which gives us some preliminary reason to suspect that, okay, maybe Weibo is messing up with the data here. But I want to proceed with the qualification. So I added a third line, the red one, which represents advertisement or sponsored trending topics. So these are like, promoting Nike shoes or IKEA furnitures and things that people pay to get on the trending list. If you compare the red line next to the blue, you see the distortion with sponsored topics is much more significant than the ones with government scandal. So for the moment, let's just say, is there manipulation going on with popularity index? Yes, but in terms of scale, that is not as pervasive or significant as a distortion with sponsored trending topics. But let's proceed to the problem of trending time. If people recall, according to Weibo's own way of presenting their trending list, the larger the popularity index is, the higher you should be able to rank on the topic list. And relatedly, the longer you should be trending. Is that the case? To measure that, I use the Spearman rule, which is essentially a measurement of the strength of correlation between popularity index and trending time. And to translate statistical language into human language, it means that the higher Spearman rule is, the more natural the correlation is. So as we can see with the control group, the Spearman rule is decently high of 0.45. And for this group, we have all kinds of random COVID-related hashtags, like what random stuff people do when they're stuck in quarantine, baking cakes using rice cookers. And on the other hand, we have the comparison group of government scandals. So these are the things that the government really don't want to appear on social media. And as you see, there's a significant drop with Spearman Rowe from 0.45 to 0.26. And this distortion is even more evident once we look at the ratio, which is calculated as popularity index over trending time. Essentially, the larger the ratio is, it means the less exposure a topic gets, because for the same amount of trending time, you need a larger popularity index. And again, when we look at the data from the second row, we can see for government scandals, the ratio is as high as 0.74, and for control group, it's only 0.50, which means that yes, the government scandals are somewhat suppressed in terms of their exposure time. So quick recap of what we found empirically. I say we found some preliminary evidence that there is distortion with popularity index. As you can see denoted by the benefits law, there's disruption with how first digits distribute across different 1 to 9. But secondly, the distortion is even more severe with trending time, as Weibo isn't even keeping honest to their own data. They're not really ranking the topics based on popularity index. Instead, they have other ways to do it, which resulted in government scandals being suppressed. So what does this mean for all of us? I think it will be boring if I just say people don't trust the internet. We all know not to trust the internet. But what I do want to draw everyone's attention to is the fact that how sophisticated trending topic list, or in general, social media has become when it comes to hiding information or promoting information to average consumers. So before you see a post being deleted, your account being blocked, you recognize immediately that there is censorship going on. But now, if you don't go through this whole statistical process, it's almost impossible for you to know, okay, is this topic genuinely popular, or am I being tricked by some of the social media? Additionally, I want to point out that this isn't a China unique scenario. In fact, if anyone still recall the scandal of Cambridge Analytica and Facebook that meddled with the US presidential election, or let's just simply say all the clickbait videos on YouTube that optimize their knowledge of YouTube promotion algorithm, it's essentially the same thing. So I want to end my presentation by just saying that social media used to be imagined as this place for egalitarian and equal voice for everyone. However, the trend that technology seems to be carrying us is towards a more centralized platform where it's really the platform companies controlling voices and disseminating information instead of average users. And this is exactly the power that we should be cautious of. Thank you.
Okay, thank you so much, Xuan. That was an amazing presentation, and I'm sure everyone was really fascinated by your research. So I now like to open our Q&A round for Xuan and ask our audience to type their questions in the Q&A or privately message me, Daniel, or Tara. Okay, so let's see, okay. We have our first question is the detected data fraud a result of state policy?
So that's a great question, and I think a great clarification point to make. So my research is focused on finding fingerprints of manipulation and how do we better detect manipulation when we look at social media data. However, it doesn't focus on the process or the mechanism. So I don't look into the black box of who is doing this. For obvious reason, that data is much harder to get. And I think the important thing to take away is that social media platforms are the proximate agents that have their hands over the data and algorithm. So there may or may not be state intervention with this, but there's no conclusive evidence whatsoever that a non-democratic regime is more likely to intervene, or China is very unique in this sense. So let's just view it as more of a platform instituted policy rather than linking it with state agents that are at least not present in the data that I'm showing today.
Cool, okay, so we have our second question. How were you able to source data from Weibo? What was the collection process like?
So the Weibo data itself has like a 1 minute / 10 minute refresh cycle that is impossible to scrape if you're trying to scrape it from outside. However, there's a huge industry that's commercialized behind Weibo that is dedicated to find out who is trending and what is trending at what moment. So there are a bunch of companies with commercialized data set that records all of this. And I think it always requires a paid membership to access those data, but they're pretty common when you kind of just do a Google search on it.
All right, and we have a third question. How did you collect the data on the popularity of government scandal-related topics, since they're usually wiped out according to the attendees' knowledge?
I think the answer to that question is twofold. One, I think even if you wipe out some trending topic really quickly, it still leaves traces, like nothing's really ever gone on the internet. And the data set that I'm using automatically records any trending topic within every 10 minutes. So if the topic was not erased within 10 minutes, I still get it. But second, I think what this research project is dedicated to show is how topics are not wiped away, like bluntly. So a bunch of these topics are still existing on China's social media. And obviously there's a limitation to it. Like I won't be able to collect data on things that are disappearing too quickly, like within seconds or a minute. But at least for topics that gain some momentum on the social media, I will be able to collect.
Okay, and we have our fourth question. Why are you interested in this specific topic?
I think it's kind of like a general interest when you look at social media, and I start wondering why am I keep seeing some celebrity names more often than others. And I got into this huge apolitical fandom world where a bunch of fans are actually trying to promote their own idols and celebrities on China's social media. So it's really an apolitical route that eventually led to a political project. I think people spend a lot of time on social media every day, and it is necessary and important for us to know what information out there is created by real users and what is, put forward by platforms/robots.
And we have our final question for time's sake. Have you tried or do you know of other research that has tried the fingerprint finding methods on other Chinese social media platforms and platforms used by the US?
So yes, there are a bunch of different methods to go about this. Some are really, really data savvy and tech savvy. They use very sophisticated computational model to do it. Some are more qualitative. I think one of the best literature on this is by Kingpan Roberts, who literally built their own social media platform in China. So they went through a whole process of setting up a company and having real people post on their platform and see how that process worked out. And there is also an abundant scholarship on US related platforms like Twitter and Facebook. So fingerprint finding is very common, but what I'm proposing here, I think, is a unique way to detect data fraud based on the trending list function, so information about information, whereas most of the research in this field right now are focused on finding distortion within individual posts, so micro-level information.
Okay, and with that question, we're wrapping up the Q&A. And thank you so much for the audience for sending in your questions. And thank you, Xuan, for the wonderful answers. And I'll hand it off to Tara to introduce our next speaker.
Yeah, so I'm super excited to introduce our third speaker, Selden. She is a first-generation Tibetan American born and raised in Ithaca, and she hopes to combine her love of science and activism by practicing medicine in refugee camps in parts of Tibet and India, all the while raising her voice at the human rights violations in Tibet under Chinese rule. I will now hand it off to Selden to present her research.
Thank you. Okay. All right, so my Mac is an older version, so I don't have the beautiful background behind me. So this is the wall, but okay, let's see. All right, so hi, my name is Selden Osho. I am a current senior undergraduate in the Barrow Lab, and I'm very excited to be presenting my research on DHRS7, a potential thermogenic activator. So as you may know, obesity is defined as having a BMI of over 30, and it's currently a global epidemic. It's particularly a problem in the United States. Here we can see a map of the US rates of self-reported obesity in US adults broken down by state and territory, with darker states representing higher rates of self-reported obesity. And it's quite frightening to see that not one state actually has a reported rate of below 20%. This growing obesity epidemic is a large medical concern due to the fact that obesity is associated with several comorbidities, such as cardiovascular disease, type 2 diabetes, and certain cancers. Additionally, the financial burden is something to consider as well, with the US paying an estimated $147 billion in the year 2008 on just obesity-related costs. So it's apparent that there is a need to understand obesity-related metabolism and to investigate possible treatment options to combat this growing epidemic. So in order to think about how we can combat obesity and weight gain, it's first important to understand this concept of weight management. So the core idea is this balance between energy intake and energy expenditure. Energy intake consists of things such as food intake, alcohol consumption, and energy expenditure consists of things such as basal metabolism, thermogenesis, or physical activity. And although a relatively simple concept to understand, the reality is that this balance can be incredibly difficult for some individuals to maintain. Past interventions have primarily focused on limiting intake or increasing physical activity, but these have been largely insufficient as seen by ongoing upwards trends of obesity. So our lab is interested in examining the energy expenditure side of the scale, particularly on thermogenesis, because it has potential in serving as a metabolic option of helping to control this vital energy balance. So first off, what is thermogenesis? Well, to start off, in our body, we have cells, and within these cells are organelles known as mitochondria, the powerhouse of the cell. And within mitochondria are a cluster of proteins collectively known as the electron transport chain. And it's these protein complexes whose function is in part to transport protons or positively charged hydrogen atoms from the innermost portion of the mitochondria known as the matrix and out into the middle portion known as the intermembrane space seen here. And this creates a buildup of protons in the intermembrane space and a less concentration in the matrix inner portion. So it's this gradient that causes protons to passively diffuse and flow down a protein known as ATP synthase, also embedded in the membrane. And it's this funneling of protons through ATP synthase that causes the production of ATP, or energy, for our cells. However, in the mitochondria of our brown fat cells, we can activate a process known as non-shivering thermogenesis when we place mice in cold conditions. So in non-shivering thermogenesis, we have the presence of this protein known as UCP1, or uncoupling protein 1, now present in the membrane where the electron transport chain is taking place. And the presence of UCP1 means that it basically causes holes to be poked in this membrane, thereby allowing protons that could have been funneled down ATP synthase to produce energy. It's now taking some of those protons and diverting them down its own channel. And this process produces heat. It releases heat, and instead of a production of the full capacity of energy, you are now burning energy as well. And we also have brown fat in humans. I mentioned mice when I talked about cold exposure, but you can see here that in humans, we have relatively no significant levels of brown fat in thermoneutral conditions. However, when we place humans in cold, we see that there is a significant level of activation of brown fat near the interscapular region. So this seems like a great solution to combat obesity. It seems like all we need to do to find a cure is to increase energy expenditure within our cells. And there have been a few compounds that have at some point been on the market and have tried to exploit this concept of burning energy through increased metabolism. Perhaps the most common example would be dinitrophenol, or DNP. And although it works similarly to UCP1 and increases energy expenditure in our cells, The problem with DNP and other similar chemical uncouplers, as they're called, is that they lack tissue-specific effects. So if we target UCP1 and we want to increase its expression to achieve the desired increase in energy expenditure, it's a much safer and reliable method because of the fact that UCP1 is tissue specific. It's only present in brown adipose tissue, which is accustomed to increases in energy expenditure. However, this can be compared to DNP and other chemical uncouplers that have been produced. The problem is that administering these compounds results in a lack of control over which tissues will have an increase in burning of energy, meaning that highly metabolic tissues such as the liver, muscle, heart, where you would not want to be burning excess energy because of the fact that they would need this energy to perform their vital functions for our body, would not be targeted. So that's the problem. How are we supposed to safely turn on thermogenesis? So the problem, just as a brief summary to regroup our thoughts, we know that obesity is a pertinent problem. We're also aware of a process known as non-shivering thermogenesis that has potential to act as a metabolic option for combating obesity in the far future. And although there are a few compounds like DNP on the market, they just aren't safe. We also know that the problem with thermogenesis is that we know very little about it. We don't know which proteins are involved in activation of this process, which proteins are directly involved in the deactivation of this process, or the whole pathway as well. So that's where my project comes in. My project involves characterizing and determining the relevance of a protein, DHRS7, in the activation of thermogenesis. So before I even knew about DHRS7 and began experiments, Dr. Barrow, my PI, and Dr. Q, postdoc in the lab, sent brown adipose tissue samples from mice, either placed in cold conditions, 4 degrees Celsius, or thermoneutral, 30 degrees Celsius, to a proteomics facility in order to determine which proteins in brown fat changed under cold exposure compared to thermoneutral conditions. And they generated a graph. The lines on the right side of the graph are representing proteins that increased in protein expression in cold conditions compared to mice in thermoneutral. On the left side, we have lines representing proteins that decreased in expression in cold compared to thermoneutral. And it was on this right side, or potential activator candidates, that my protein candidate was narrowed down and ultimately yielded a list of several different candidates, one of which was DHRS7. And like I mentioned before, my protein is DHRS7, also known as dehydrogenase reductase 7. It's generally uncharacterized protein in general, but there is a paper stating that it can be used in the reaction of ethanol to acetaldehyde, the metabolism of alcohol. And in brown fat specifically, it's not clear about what its significance is. All we know that it resides in brown fat as well, and this symbolizes a sense of novelty and excitement in the field. So I'll give a brief overview of my project workflow. Like I mentioned, Dr. Barrow and Dr. Q performed the preliminary proteomics screen where they identified a large list of potential candidates. Then Yang Liu, one of the graduate students in the lab, narrowed down this list further using a variety of methods and experiments. And my project began ultimately with the literature review of DHRS7 and assessing its novelty and function in thermogenesis. I later went on to characterize the protein in several different tissue types, some of which I will be showing today using Western blots and assays. And I'm currently in the stage of generating a knockout cell line, which I will talk on later briefly in future studies. So, okay, so here you're looking at an SDS page immunoblot, also known as a Western blot. And I tested tissue samples from mice placed in either thermoneutral or cold conditions for 1 day, cold conditions for 4 days, or cold conditions for 7 days. And the bands here are representing protein concentration. So a darker band is telling us there is more of that protein present within the tissue. And we see that UCP1 expression actually increases as we prolong cold exposure, which is something that we expect because we know that thermogenesis is activated under cold. Interestingly, when we probed for DHR7 protein levels, the expression was seen to follow the trend of UCP1 as well, and also increase in expression under cold conditions. And this is important because it suggests an association between DHR7 and UCP1, aka thermogenesis activation. We also looked at liver tissue samples, which I'll talk in the next slide, but this is just a Ponzo stain showing that there was even loading of protein in each of the wells to conduct this Western blot experiment. Moving on to liver tissue, we used the same mice. The reason why we tested liver is because of the fact that like bat, brown adipose tissue, liver is a highly metabolic organ, but unlike brown adipose tissue, it does not possess UCP1 and therefore would not perform thermogenesis. We therefore would expect to see no change in protein expression of DHR7 even under cold because there's no thermogenesis or UCP1 to even activate in the first place. And that's exactly what we saw. The line of DHR7 is the one above. This is just some non-specific binding that occurs sometimes with antibodies. But the line above shows expression of DHR7 in thermoneutral versus several different cold conditions, like I mentioned in the past slide. And that's what we saw. It's great to see that there is a consistent expression of DHR7. There's no increase under cold conditions. And this is significant because it suggests that DHR7 has potential in being an activator of thermogenesis specific to brown fat tissue. And so to summarize the results that I highlighted in the data today, we found out that DHR's expression increases as UCP expression increases as well in brown fat. And we also discovered that DHR7 is usually induced in expression around day 1 of cold exposure, so relatively early within the timeline of thermogenesis. And lastly, we also highlighted that DHR7 is a tissue-specific activation in brown fat of thermogenesis. So future studies, we're currently in the process of establishing a knockout cell line, meaning that we utilized CRISPR-Cas9 technology to delete DHR7's gene from our bat cell line. And in the future, we'll use these cells to examine the effects on thermogenesis to see, okay, if we delete this gene, are we going to see an increase? Are we going to see a total deletion of thermogenesis? And if we do see that, that's further promising for our results that DHR7 does in reality have an impact on the activation of thermogenesis. So there are further characterizations that have to be made regarding this protein, but we hope that the future will yield promising results. And yeah, thank you so much. That's my presentation.
Thank you so much, Selden, for presenting your amazing research. And we're now going to open our Q&A session. So if you have any questions, go ahead and type them into the Q&A, or you can privately message me, Daniel, or Neha. All right, so our first one is already here. Are there any reasons why examination stopped at 7 days?
Yeah, so honestly, to be completely honest, the researchers who did perform the mice experiments are my PI and the graduate students. But in terms of why we stopped it exactly at 7 days, I think that's just the length of time that's needed to induce UCP1 expression and induce thermogenesis in brown fat of the mice that we were looking at. So past a certain point, it doesn't really become relevant anymore because there's no purpose in looking at proteins that will turn on much later in the timeline of thermogenesis activation. So yeah, it's all based on UCP1, the importance of these potential candidates. Yep.
Great. Okay, let's see what else we have here. Are there any other tissues besides brown fat that can perform thermogenesis?
Yeah, so in mice at least, we do know of something known as beige fat, which I didn't touch on because I didn't want to add like unnecessary details to the presentation that could confuse people. But we did test in beige fat known as inguinal fat. And beige fat is different from brown fat in that it is derived from white adipose tissue. So like the chub that we have on our body. it's derived from white adipose tissue, but it has similar characteristics to brown in that it does have UCP1 expression as well. So in humans, however, it's a little bit more complicated because there's a debate on whether the brown fat that we have like in our interscapular region that can be induced under cold is either more similar to brown fat characteristics in mice, or if it's more similar to the beige inguinal fat in mice. So it's kind of debatable in humans, but in mice for sure there's beige fat.
Cool. So our next one is, what are the implications of an increase in brown adipose tissue?
Great question. Well, I guess this is more for a long-term goal, because right now we don't, like I said, we don't even know a lot about thermogenesis besides the fact that under cold it's induced, and UCP1 is a very important protein in this process. But I mean, in the future, if pharmaceutical companies are able to manufacture a drug, for example, that can increase your energy expenditure, increase your activation of thermogenesis in brown fat, that would mean that, okay, now we're able to effectively combat obesity and weight gain in individuals who maybe aren't able to lose weight as efficiently as, like a metabolically healthy person would be able to. So definitely a gain in energy expenditure is the future. Yeah.
All right, and the next one we have is there a reason why there is an abundance of brown fat in mice but not in humans?
Yes, great question as well. So this is interesting because in mice, there is almost a constant expression of, or a constant like volume of brown fat in the mice. But in humans, at least, when we're infants, we have much more brown fat that is active. And as we transition into adulthood, we lose the majority of that brown fat. And it's true that in infants and mice, you have the baseline level of thermogenesis occurring in your brown fat, but in human adults, you need to activate that brown fat. Yeah, so.
All right, and we've got time for a couple more. So our next one is, how much more work needs to be done to establish that the association between DHRS7 and UCP1 is one of activation and not just similar expression trends in cold temperatures?
Okay, that's also a really good question. So that's more, I would say that the establishing an association between DHR7 and UCP1 is so far what I've completed. Just like looking at protein expression, stuff like that in several different tissues that are associated with thermogenesis. But in order to really establish whether DHR7 is truly important in activating thermogenesis is the future study of looking at the knockout cell line. Because if we delete DHR7's gene in our brown fat cell line, and we harvest those cells, we perform Western blots and qPCR, which is basically detection of mRNA levels. And all of a sudden we see that UCP1 expression is significantly decreased, or there's no UCP1 present. That would significantly and heavily indicate that DHRS7 is vital in that activation, because if you're taking away an important protein and you don't see activation of thermogenesis anymore, it's kind of like a much more concrete test, I would say, validation.
Awesome. And I think I have one more question for you, Selden. So, is there a reason temperatures were held closer to 30 degrees Celsius as opposed to more common outdoor temperatures for this region, so around 20 to 25 degrees?
Oh, okay. That's a good question too. I don't know how much I can answer, to be honest, because I didn't design that part of the experiment, but I do know that 30 degrees Celsius is considered thermoneutral for the mice that we like housed and used for the experiment. For the region outside, it's a little chillier than what we would consider as thermoneutral, because there is still a bit of brown fat activation. So it's more of just like keeping things constant. Yeah. Thank you so much.
All right. Thank you so much for those great questions from the audience and those great answers from Selden. So for our fourth presenter, we have Gabriel. And so Gabriel is a senior from Miami, Florida, majoring in government with a concentration in political theory. And in the future, he hopes to become a professor. We will now hand it off to Gabriel to get started.
Thank you so much for that introduction, Tara. I really appreciate it. Perfect. So, hello everyone. My name is Gabriel Vergara, and I am a senior majoring in government with a focus in political theory. Tonight, I will be presenting on what I have entitled "A Tuning Fork on the Relation Between Fidel Castro and Antonio Gramsci's Intellectuals." This evening, I have divided my presentation into 4 parts. First, I will discuss what led me to pursue this research project. Second, I will cover some of Marxism's basic ideas and terms. Third, I will introduce Antonio Gramsci and Gramsci's theory of intellectuals. And finally, I will apply my Gramscian analysis to Fidel Castro. Before I dive in, I really just want to acknowledge a limitation of my research, which is that I only examine Fidel Castro's political thought from 1953 to 1968. And I would be happy to elaborate on why I chose this specific time frame during the question and answer period. So broadly, my research focuses on Marxist political mobilization and the maintenance of political alliances. The question driving this presentation is, how does Antonio Gramsci's theory of intellectuals help us understand political mobilization? In order to answer this question, I turn to Gramscian scholarship. But in order to concretize my analysis, I use Fidel Castro as a historical example to understand Marxist political mobilization. With a better understanding of Gramsci's theory of intellectuals, Marxists will be better able to understand political mobilization and understand the role that intellectuals play in this mobilization. To begin, my relationship to Marxism has been complicated, to say the least. My paternal grandparents came to the United States as Cuban immigrants following Fidel Castro's rise to power. You can see my grandparents and me in the top right photo, and then Fidel Castro in the bottom right photo. For some background, Fidel Castro was a Cuban revolutionary who overthrew the American-backed Batista regime in 1959. However, Castro's revolutionary history began well before 1959. In 1953, Castro led an attack on the Moncada military barracks just outside of Santiago de Cuba. Castro was unsuccessful and was arrested and tried for this attack. At his trial, Castro, a university-educated lawyer, delivered his famous "History Will Absolve Me" speech. But despite his eloquence in his defense, Castro was jailed for 2 years. After being released from prison, Castro fled to Mexico to plan a second revolutionary attempt that toppled the Batista regime. Castro and a band of revolutionaries arrived in Cuba in 1956 aboard the ship Granma. Over the course of the next 3 years, until 1959, Castro and his band of revolutionaries engaged in a guerrilla struggle against the Batista regime. Ultimately, Castro and his revolutionaries were successful and ousted Batista. Eventually, Castro came to leave the island and declared Cuba as a socialist state, espousing Marxist views. In college, as I started to explore Marxism, I continually turned to Castro and to Cuban socialism. My hope is that my research will be an adequate homage to my grandparents who fled Cuba and came to the United States. Moving on to part 2, many people are familiar with Marxism as an ideology, but might not be familiar with Marxist theory. So I briefly want to go over this so that everybody's on the same page. To start, Marx believed that society was being increasingly divided into 2 social classes, the bourgeoisie and the proletariat. To Marx, the bourgeoisie was the class that had consolidated the means of production, such as machinery and other equipment, leading the bourgeoisie to accumulate large amounts of wealth. Because the bourgeoisie had consolidated the means of production, the proletariat was increasingly forced to sell their labor in order to earn wages. Through the process of selling their labor for a wage, the bourgeoisie was able to extract surplus value from proletariat labor. But simply, the proletariat worked adding value to a product, but would not entirely be compensated for the value that they added to the product. Because the bourgeoisie was not fully compensating the proletariat, the bourgeoisie was able to extract large profits, further consolidating their wealth. As a result of this economic exploitation, Marx believed that capitalism was vulnerable to class revolution for two reasons. First, the capitalist system of exploitation was highly unstable. Oftentimes, there were economic crises, such as recessions, that would further exacerbate socioeconomic inequality. Second, capitalism created conditions of collective exploitation. As the bourgeoisie continued to consolidate its wealth, the number of proletarians that were exploited would increase. As the proletariat grew in size, there was a possibility that this exploitation would be recognized and would be acted on collectively through a revolutionary struggle. Here, Marx believed that as the number of proletarians grew, consciousness, or the awareness of exploitation, would grow. As this consciousness grew, Marx thought that the proletariat would lead a revolution that would topple capitalism. To catalyze this revolutionary anti-bourgeois struggle, Marx hypothesized that a portion of bourgeois intellectuals would recognize the rising proletarian movement and join the proletariat. With the help of these intellectuals, the proletariat would seize power and abolish private property, leading to the end of bourgeois oppression. In the Marxist tradition, it has been particularly onerous for revolutionary leaders to unite the peasantry and the proletariat in revolutionary struggle, because these groups have differing goals and varying levels of consciousness. Because of these hardships, 20th century Marxists, such as Vladimir Lenin and Franz Fanon, developed theories of intellectuals, or individuals who were to unify and mobilize the peasantry and the proletariat. For example, Lenin developed his theory of the vanguard party, and Fanon developed his account of the native intellectual. However, for this project, I analyzed Gramsci's theory of intellectuals. But first, I need to answer the question, who was Antonio Gramsci? Antonio Gramsci was a 20th century Italian communist. In the early 1920s, Gramsci and other Italian communists formed the Italian Communist Party. And within this party, Gramsci rose to prominence and was elected to the Italian parliament. However, in 1926, as Italy succumbed to fascism, Gramsci was imprisoned for his communist beliefs. While in prison, Gramsci worked on various scholastic projects, and following his death, which was in prison, Gramsci's work was synthesized and anthologized into what we have today, which is known as the prison notebooks. I seek to make my intervention regarding Gramsci's theory of intellectuals. In the prison notebooks, Gramsci distinguished between traditional intellectuals and organic intellectuals. For the most part, few Marxist scholars have analyzed how Gramsci's vocabulary of intellectuals relates to political mobilization. Understanding the vital role that intellectuals play in political mobilization can help Marxists better mobilize diverse groups for radical struggle. In my project, I define and characterize traditional intellectuals and organic intellectuals according to three categories: class origin, the content of intellectual work, and social function. On the one hand, traditional intellectuals refer to those who are closely connected to and help perpetuate bourgeois rule. Because of their links to the bourgeoisie, traditional intellectuals are disconnected from the masses, working to maintain and to entrench the status quo, one of oppression. On the other hand, organic intellectuals are those whose social function is to elevate the consciousness of the proletariat and the peasantry in order to develop a new power configuration, one free of exploitation. Put another way, organic intellectuals work closely with the peasants and the proletariat, increasing their awareness of bourgeois exploitation, mobilizing revolutionary action. More technically, one can say that organic intellectuals lead a dialectical relationship with the masses. With this in mind, I move to classify Fidel Castro as an organic intellectual. Through this case study, I hope to reveal how Fidel Castro mobilized a diverse revolutionary coalition in Cuba. Despite the fact that Castro was originally from a bourgeois family and was a lawyer, Castro did not use his privilege or his education to further bourgeois exploitation. Instead, because of Castro's social function, which advanced the Cuban Revolution and elevated the consciousness of the proletariat and the peasantry, Castro can be classified as an organic intellectual. For example, Castro fought to secure agrarian reform for the peasants and better working conditions for the proletariat, so that neither group would suffer exploitation. More specifically regarding the peasantry, Castro undertook large-scale agrarian reform to redistribute land to the peasants, so that the peasants would own the land that they worked. Similarly, Castro lived among and learned from the peasantry during the Cuban Revolution. For example, in the mountainous Sierra Maestra region, the peasantry taught Castro about agriculture and other issues vital to the peasantry. Here, I claim that Castro's relationship to the peasants and to the proletariat can be seen as educative and dialectical, mobilizing the people and contributing to the creation of a new society. This rather brief summary shows that, in fact, Castro was an organic intellectual from 1953 to 1968. With this in mind, I want to thank you all for listening, and I look forward to your questions. Thank you.
Thank you so much for that wonderful presentation, Gabriel. So the Q&A round is now open. If you have any questions, feel free to type them in the Q&A, or you can private message them to me, Daniel, or Neha. So, okay, how about we start with, why did you choose to focus on Fidel Castro's political thought from 1953 to 1968?
Well, I think that that's an interesting question, partially for the later date, not necessarily the first date. In regard to 1953, I believe that most Cuban historians would demarcate that the attack on the Moncada military barracks as the start of the Cuban Revolution. So that was kind of a very obvious choice for me on where to start my research. But 1968, really the event that I focused on there is the Soviet Union's invasion of Czechoslovakia. And I think for that, I might want to give some background. So Czechoslovakia at the time was in the USSR's sphere of influence. And they started to pass some neoliberal reforms that, opened Czechoslovakia up more economically and more than the Soviet Union would like. So the Soviet Union invaded Czechoslovakia. And surprisingly, Fidel Castro actually supported the Soviet Union in their invasion of Czechoslovakia. And what I think that this instance really illustrates is that by that point, Fidel Castro had already consolidated power, and his relationship to power might have been different than it was in 1953. Perhaps what he's doing in 1968 by supporting the Soviet Union is supporting and entrenching a certain power, whether that's proletariat power, peasant power, that really is indicative or is more characteristic of a traditional intellectual who would try to entrench a certain form of power. So at that point, I would argue, and in my view at least, from 1968 onwards, Fidel Castro is no longer an organic intellectual, but a traditional intellectual. So for the purposes of trying to keep my analysis very neat and to show especially the role that organic intellectuals play in mobilization, I thought that it was important to stop my analysis at 1968.
Awesome. So our next question for you is, how has your research into Marxism and Fidel Castro shaped your opinions on US politics and social structure?
Yeah, that's a really good question. I think that it definitely has played an influence. I've probably read the Communist Manifesto for my research upwards of like 5 or 6 times already. And I think the biggest thing that stuck out to me is a lot of Marxist ideals aren't that radical. And Marx gives a list of about 12 pointers on what communist society might actually look like. And the first one is the abolition of private property, which obviously hasn't happened. But there are a lot of things like limiting the work week or a graduated income tax that are indicative and characteristic of society today. There are things that we just consider the norm. So in regard to US politics, it showed me that perhaps the goals of Marxism or the spirit of Marxism isn't as lofty or as radical as some politicians might want it to be.
Great. So our next question starts off by wanting to thank you for your insightful presentation. And then they would like to know if you also consider Lenin and Guevara as organic individuals, because like Castro, they were from educated bourgeoisie backgrounds.
Yeah. So in regard, I'll start with Che, and I think Che is an organic intellectual, especially probably more than Fidel Castro. You know, he did a lot of voluntary labor in Cuba, and he really pioneered trying to spread Marxism throughout not only Latin America, but into Africa. And I think he, more than Castro, played this social function of trying to mobilize the masses to end exploitation. In regard to Lenin, I think that's a bit of a more complicated question. So I would argue that at one point, perhaps we can consider Lenin's mobilization of the masses as him being an organic intellectual. But I also don't want to lapse into such a simple analysis, and that's because of Lenin's theory of the vanguard party. And when Lenin discusses the vanguard party, he presents it as an extremely, extremely narrow group of people. In his text, he actually refers to the vanguard party as, and I quote, professional revolutionaries. So by restricting who's able to contribute to this communist project, this new society, I would argue that that exclusion perhaps might push him in the direction of being more of a traditional intellectual. So it might be a bit of a mixture of characteristics. He might have the social function of an organic intellectual, but the content of his intellectual work, for example, might be more indicative of a traditional intellectual.
Great. We have another one. So can you think of anyone today who approximates an organic intellectual?
Yeah, that's a really good question. And I think that the example that came to mind to me the most is Alexandria Ocasio-Cortez. And I think that that goes back to the way that she mobilized people in her district. She got, if I'm not wrong, over 70% of the vote in her first election. And just the way that she's maintained a connection with those people, not to mention the fact that she comes from a very working class background. She really empathizes with, the struggle of the everyday individual. And also just in Congress, what she's pioneered and the agenda that she's pursued hasn't been one that really perpetuates the status quo in the United States. You look at, for example, the Green New Deal, and that's been something that the status quo would consider as unpopular, or perhaps even irrational. So I think that she's an organic intellectual. However, I also want to flag a potential question for me going forward with this, which is perhaps institutions themselves can change an individual's intellectual status. So I'll use the example of AOC, which is perhaps now that she's in Congress, is Congress going to make her more detached from the masses? Are there going to be vested interests that push her more in the direction of being a traditional intellectual that would make her disconnected from the masses? And I think that that's a question that really hasn't been explored in Marxist thought and probably deserves some attention.
Cool. So we have two more, and then I think we're going to have to stop there for time's sake. The first of which is, so this attendee feels like the results of the study might be difficult to digest for individuals who, for better or worse, view socialism as a threat to democracy. So if your project could gain a wider exposure outside the Cornell community, do you think your findings might not have the reach they could or should due to how they frame individuals such as Castro? And how would you account for this?
Yeah, I think more than anything, especially given the fact that like my grandparents suffered, the atrocities and the horrors of the Cuban Revolution, I don't mean to paint a romantic picture of the Cuban Revolution or of Castro. At the end of the day, I leave it to historians to make historical judgments. But I do think that a lot of times socialism has lapsed into autocracy. And that's something that we need to acknowledge in Marxist scholarship. But I don't necessarily think that that's the only way to go forward. I think something that as Marxist scholars want to do is continue to rethink how we can promote democracy, promote a plurality of voices being engaged in this project to end exploitation. And I take that view. I don't necessarily think that socialism needs to be constrained. And in my second chapter of my thesis, which I didn't present on here, I kind of argue that you can have at least this very pluralistic society, but one that uses at times some coercion, but also consent gained through things like voting to actually foster this sense of democracy and contribution.
All right, and our last question for your Q&A round. Do you think understanding Castro as a Gramscian intellectual gives him more credibility as a political theorist and figure? And in general, can we use this way of thinking to legitimize communist thinking in the West?
Yeah, I think in regard to using Castro as a case study, I think part of that went back to my Cuban roots, but also just Castro is really excluded from larger debates on Marxism and Marxist thought. And particularly that might be because most of his work is preserved in speeches. He never wrote this a large text that really went on to be something like the Communist Manifesto. But I also think that it goes back to the hegemony of Western thought and the Western experience. So being able to understand these non-Western experiences is really imperative for the construction of a holistic understanding of Marxism. In regard to digesting Marxism in the West, I think that there have been a lot of pushes to really make it something that's stomachable. So I have in mind this one author who actually used the Gramscian framework, and really what he argued is perhaps socialism can be achieved through liberal democratic institutions, through the parliamentary system in the West, maybe perhaps the presidential system here in the United States. And I think that that's interesting. I think that it's one potential way to look at it. However, I want to really kind of shy away from that because at the end of the day, Marxism as a project is one that's revolutionary and that's a radical rupture with the bourgeois tradition. And by working through bourgeois institutions, we at some points are going to need to replicate the structure that the bourgeois had. So I really think that by working through liberal democratic institutions, you lose something. You might be able to reach an approximation, something that looks similar to Marxism, similar to communism, but it won't necessarily be it in its fullest form. So that's how I think we need to view it in the West. Perhaps struggle is the right way, but struggle might not necessarily be a violent revolution. It might be, protesting in the streets. It might be civil disobedience, and it might just be raising our voices that way. I think struggle takes on many forms.
All right, that will conclude our Q&A round for Gabriel. Great questions and great responses. Thank you so much.
So much.
And with that, I'm going to hand it off to Neha to introduce our final speaker.
Thank you, Tara. So concluding our amazing lineup, we have our fifth and final speaker, Alex. So Alex is a third-year undergraduate pursuing a Bachelor of Architecture and a minor in Design and Environmental Analysis Research. This is his second year conducting research, and he's currently working as a research associate in the Sabin Design Lab. I'll now hand it off to Alex to start his presentation.
Thank you for the introduction. I am gonna share my screen right now. Just a second. Are you guys able to see the screen? Okay. Yep. Thank you. So my research is on sustainable architecture and aesthetics. The research title is Biointegrated Photovoltaic System, and the idea is to integrate energy, food, water, and shelter into a solar array system. The research is conducted in the Sabin Research Lab in the Architectural Department, and it's funded by the National Science Foundation, Granier Foundation, and it's in collaboration with the DFAC lab in Arizona State University for fabrication of solar panels. So in introduction, I'll start with introducing the building sector and the carbon emissions. So the building sector contributes to 40% of greenhouse gas emission. And then if we look at a pie chart here, you can see that 47 of the CO2 emission comes from the building industry compared to transportation and other industries. And then if we take a closer look at energy usage, the building sector creates the highest amount of energy usage due to many needs, such as heating and cooling of buildings, and then also construction material itself, the production, and then the construction of these buildings also contribute to our energy usage. So why sustainable design is one of the questions that many people ask, but the answer is that if we do not take action right now by 2100, there are 3 scenarios that are given out by the International Panel of Energy. And then the suggestions are as listed, and then the consequences are not good. So if we think about this, we can already see that climate change is already occurring. The water have started to melt and the sea level is continually rising. So when we're designing for sustainability and architecture, not only we have to think about preventive and reversive methods, but we also have to think about resilience and adaptability. So I want to go ahead and give a brief background to PV cells, which are solar panels. PV cells are one of the most commonly farmed energy system, but they're also currently underutilized. But then they're by far the most dependable technique to get solar energy, mainly because the sun provides like enough energy to cover the world's annual energy demand in an hour, but we are not technically doing a very great job at that. If we look at this diagram, solar panel only accounts for a little bit of our total energy consumptions. And this reason might be because solar panel also have a variety of cons that I want to address. So the first con is basically self-shading and linearity. So because solar panel requires tilt or angle, it creates self-shading, and this leads to space inefficiency and self-shading. And then the other part of this is the overheating and the necessary for drain back issues, because solar panels overheated, solar panels create additional inefficiencies, which requires additional cooling systems. And then I'm just gonna go over a brief way literature research done. When we wrote this paper, we looked into other projects which involve kinetic tracking, which the pros of this is like a more consistent access to solar irradiance values throughout the day, but then the cons are maintenance issues. And then other projects such as transparent solar panels like are utilized, but then in this case, many of these are non-site specific, so they're just plugged onto the side of the building. And then other material innovations include using thin film solar panels, which offers flexibility, but also create self-shading due to its flexible nature and forms it creates. The main approach that our research decided to do is to do analysis of existing biological precedents. So we realized that instead of taking or trying to invent a new system, what if we do a background research on biological system that already involves solar tracking and solar collection systems. So the first system that we look at is sunflowers and its heliotropism and its orientation. So beginning with this biological adaptation, which is the heliotropic mechanism, it includes the exon in a plant hormone, which causes the elongation of cells and shoots and involved in regulating plant growth. So and then the next biological system that we analyzed was basically the livingstone plant and how it contains 3 different structural cells, and then which contain different mechanisms. And this allows for the biological organism to cool itself down. The plant lives in high light in subterranean area site, so it's necessary for it to have self-cooling mechanisms. And the next precedent that we look at is cyanobacteria and how it decided to pack cells closer to each other to combine efficiency in transferring energy and also working together as a group of cells. This also inspired us to look into coral reefs and how they have this symbiotic collection, solar collecting system with algae, where algae produce photosynthesis that requires energy for the coral reefs, and then it in turns create carbon dioxide and nutrients for the algae. So it's like a connected system. And what we wanted to do is take aspects from all four of these biological precedents and try to inform how we design our solar panel array system in our research. So the research method is trying to find a biointegrative algorithm for form finding. The form finding that we want to base it off is basically the sun path, because we want to make it site specific depending on location. So depending on where we are situated in the earth, the sun have a different path depending on that location. And then we did a bunch of simulation that kind of does like heliophobic and heliotropic, just to see the comparison of how the sunlight changes. And then we decided to go with the heliotropic part, the simulation form, as it was proven both in simulation and also in natural precedents that this was more efficient and was able to gather more sunlight. And what we found out was that the heliotropic orientation prevents self-shading, whereas the heliophobic forms introduces the self-shading elements of the form covering itself. The way that we use simulation and computational is to develop an algorithmic workflow that takes in site-specific sun path data to subdivide a given geometry into highly efficient photovoltaic cell assembly based on their solar irradiance value. So solar panels have this minimum efficiency theorem, where basically cells have to be grouped with similar irradiance values to be the most efficient, because the panel is only as efficient as its least efficient cells. So we decided to band cells with similar irradiance value into 4 bands, and then subdivide those cellular PV cells into smaller cellular components. And then we decided to incorporate cellular packing and morphology that we intake from cyanobacteria, and then what we learned from them, and then basically created a taxonomy of PV cells that we could utilize, and then kind of utilize to build this pavilion or this system. And to support these PV system, we created 3D printed nodes, and these 3D printed nodes basically support the PV systems that is held up. And these are some diagrams of it. And then connecting from the top layer, the PV cell is like a system of dichroic shells that serves as light filters. And these are connected through the middle layer node, and which is basically a geometry. The nodes are basically a geometry informed from the line work intake from the top layer cells. And then these are more diagrams of it and a closer look at how they are created. And then the bottom layer nodes basically attach the middle layer system of dichroic filters to a structural membrane. And then we decided to further subdivide, do a more in-depth analysis of how these things are subdivided. And we analyze panel areas and their efficiencies and how much offsets they're required to create these cellular taxonomies. These are the iterations, and these are more pictures and more diagram of the process that went through. And then these are the more color-coded iterations of how we dissected between the 5 different bands of different cellular irradiance values. The next adaptation that we did was basically from light scattering livingstone plants, where they have 3 different filter systems, which is basically what we kind of did with the PV cells and the dichroic filter, and then which leads to a shaded interior core. And then this was our structural system analysis and drawing of each component that is required to build this hierarchy. And then we decided to also incorporate cradle-to-cradle materials, such as recycled HDPE frames, and then readily available recycled aluminum pipes, and then 3D printed notes from recycled water bottles. So those are the three materials that are utilized in this systems. And basically, we also incorporate technologies such as dichrorophyll for light filtering, and then PV cells for energy generation. And this is a diagram of the hierarchy. And then the last step is basically incorporating the symbiotic relationship with nature. And our first approach was to go with the agrovoltaic system. And because the arrangement of the PV cells are in heliotropic configuration and light gathering structure creates an ideal ecosystem to grow crops in partial shade, which leads to high production yields and better water usage. This also decreases CO2 at the same time because plants reduce the CO2 during the day. And then at the same time, the amount of transpirational water loss result in the PV cells to be cooler during the day. And then also since the efficiency increases, the renewable energy production rate also increases. The water retention times in the soil is also increased due to the shaded core. And then all of this interconnectedness of biological functions and symbiotic relationship found in nature presents the possibility to design a system that is mutually beneficial and integrate sustainable energy with harvest, conservation, shading into one synthesized structure. And the result is basically a photovoltaic assembly that incorporates energy, food, water, and shelter by employing computational design and simulation algorithms. And then the second part of this whole research is to basically fabricate this and prototype it. So this was one of our prototyping photos of the 3 nodes and the aluminum tubes that connects it. And then basically this is our drawing that accompanies it. We also incorporate digital fabrication techniques such as laser cutting to cut our PV cells into custom shapes of these triangular cells, which match our panels. And this was basically the system that we decided to prototype because instead of deciding to try to model or like prototype a smaller version of the pavilion, we decided to prototype a smaller version of a panel to be able to introduce the idea of trying to see this fit in different contexts. And then this is our a more closer view of the created prototype with 3D printed nodes and then PV cells with light filters. And then the other, the difficult part of this was basically trying to keep track of all these custom 3D printed nodes. And we decided we developed a Python script to be able to label all these nodes in like order. And then these are how we label the node. Basically, we took like the center point of the mesh and then basically projects a line to the closest point on the mesh. And then that is basically where our labeling is introduced. And this helps us keep track. So in conclusion, the algorithmic methodologies developed aim to offer a toolkit for PV integrated structural design, whereby both the parameter of energy conversion efficiency of the array and aesthetic quality and experimental qualities are also considered. Hence, SAA does not pose like a singular pavilion, but a system and an innovative approach that is adaptable to varied contexts. So the research basically is a system that is adaptable since we're dealing with an instance of a system that can be scaled, contextualized, aggregated, and transformed in multiple ways to respond to functional urgencies and design priorities. And this would be the conclusion of my research presentation, and special thanks to my professor, Jenny Sabin, and then other members in the Sabin lab, and then also the facilities in both Cornell AAP and Arizona State University. And thanks to the grant foundations as well, and anybody who contributed in this project, and also CURBx. Thank you.
All right, thank you so much, Alex. That was great. And I now like to open our final Q&A round for Alex and ask our audience to type their questions in the chat or privately message me, Daniel, or Tara. And we already have some questions. So our first question, first they want to say that they're blown away and that was an amazing and very in-depth presentation. And their question is, are there any potential drawbacks or obstacles in the proposed design itself or in developing the system?
There were a lot of drawbacks in the sense that where we moved from fabrication, from designing the system to fabrication, there were a lot of issues with the 3D printed nodes and then how our overall prototyping works. So basically the way this research is formed is basically we take the methods and then we prototype it based on the created model, but then we face a lot of difficulties and there were a lot of, since this was also a design research project, there was a lot of going back between iterations. And that I see as one of the most difficult part of conducting this research.
Okay, great. And we have our second question. How large would these arrays have to be? Also, Cornell is directly involved with a number of solar farms, which might be useful as potential locations for prototypes. Have you reached out to anyone regarding this possibility?
We haven't reached out to Cornell to develop these PV arrays, but then the current trajectory of this research is basically to create, since we're working with algorithms and workflow that serves as toolkits, this system are basically, we imagine these systems to be have the ability to aggregate in different scales, such as like an actual PV farm or like a pavilion in this sense, or like addition to the roof or like a facade. And those are the next steps that we're working in our lab to transform the algorithms and the toolkit we have into different site contexts. And then what we are also working on is building the pavilion in different sites, as it is proven to be working in different sites. So I think it will be a good input to contact Cornell and then also as a prototype the system. So thanks for the question and then the comments. Thank you.
Yeah, okay, and we have our next question. Why were triangles chosen as the basic building for the PV structure?
I think triangles wasn't part of our initial subdivisions. Our initial subdivisions were more square-like. However, as we were forming these panels, there was like a necessary need for it to be more organic as we're following this heliotropic structure or like base geometry. And then basically, if I could annotate, I don't know if that's a good idea, if I could annotate on, could not annotate, but then I hope you guys can see the cursor, but then this entire cell is basically a huge, a shape that is built out of many different edges. So like, it's like one of, I wouldn't say it's like a polygon, but then it's like, I would say it's like a 35 sided polygon, I guess. So basically to generate a 35 sided polygon, the most efficient way would be to use like a smaller polygon such as triangle to aggregate a system that involves like 35 different edges.
Okay, we have room for 2 more questions. So our fourth question is, do you expect solar power to become a majority source of energy for the world in the future? If so, when do you expect solar power to become prominent in the energy industry?
I think a combination of renewable energy systems would possibly prove to be the next thing. Well, where it isn't just solar panels, but then I would also argue that we need to innovate. We need to think about innovating system that incorporates different types of energy generation systems and different types of system into one unified structure, or like try to synthesize a variety of issues together, such as like the issues with farming and both solar panel requires a lot of land use. So by incorporating those two systems into one synthesized structure, we imagine that we could propose something that, you know, follows the resilient land use model by trying to incorporate two of the system and then create like a positive feedback loop between the two systems of like agriculture and PV. So depending on the context and the program of like different scenarios, like I could see different types of renewable energy sources trying to, you know, work together with other renewable energy sources or like other programs. And I could see that really as the future of where we should be taking in terms of sustainable design.
Okay, and our final question, how does the role of aesthetics play into sustainable design?
I think the role of aesthetics is important in the sense that aesthetics really is like the driver of why people decide to do certain things. So I would argue that if we were presenting this to a client or like whoever walks by this, like we want them to be inspired by solar panels and sustainable design and sustainable architecture. And we want to incorporate sustainability into sustainable design and PV array systems because people often treat these as industrial components or like industrialized or mechanized components, and they don't really consider these as aesthetics or architecture. And this project basically starts to consider by designing with light energy, food, shelter, all into consideration to really consider how this pavilion might interact with people visiting as well.
All right, and with that last question, I would now like to conclude our Q&A round for Alex. Thank you once again to the audience for the wonderful questions, and thank you, Alex, for the wonderful answers and the presentation. And with that, we've reached the end of our speaker list. I will now hand it off to Daniel to wrap up the conference.
Wow. I mean, that was great. I want to again thank all 5 of our amazing speakers, Stephanie, Shuen, Selden, Gabriel, and Alex, for taking the time out of their schedules to share the research they're passionate about. I'm not sure if you guys have this functionality, but please click the applause reaction to give them a virtual round of applause if possible. We've never had such an amazing array of diverse topics before at CURBx, so I'm really very, very happy right now. I hope each of you were able to learn something new from all the presentations, as I know I certainly did. If you guys still have questions, I will drop the presenters' net IDs below so you can reach out to them directly. Also, if you'd like to give me any feedback on CURBx, I would absolutely love to hear it. I will include my net ID with the speaker emails. Thank you again for being such a wonderful audience and asking such insightful questions. In a normal semester, you guys would all be eating insomnia cookies and pizza while listening to the research presentations. So hopefully we'll be able to get to host an event more along those lines soon. I appreciate you guys joining us this evening and have a great rest of your day and stay tuned for CURBx next semester.